Example number 2, highlighting learning target 1.2b. Into what set of real numbers should the result of adding the square root of 17 and 4.0 be categorized? So take a moment and think about how you might approach this example. Hit pause and work through the example, and once you've completed, hit play and we'll work through example number 2 together. Okay, looking at the question, it is broken down into 5 different sections, asking about the set classifications of the square root of 17, 4.0, the resulting sum, and then asking why. And so when we think about the set classifications, these are the sets of natural numbers, whole numbers, integers, rational numbers, and irrational numbers. And so when we consider the set classification of the square root of 17, what we need to do is convert that to a decimal. And when we convert the square root of 17 to a decimal, we see that the answer or the result is 4.12310562556, and it will continue forever. And so when we think about what the set classification would be, we can immediately determine one of 2 options because of the decimal. And so we either have a rational number or an irrational number. Now, thinking about the definitions of each, a rational number is a decimal that either repeats or terminates. And so looking at the decimal form of the square root of 17, we realize that it does not terminate, it goes on forever, and there is no discernible repetition or repeatable pattern within the decimal. So it does not repeat and it does not terminate. That leads us to an irrational number, which an irrational number in decimal form does not terminate and does not repeat. And so we can conclude that the set classification for the square root of 17 is irrational. Now looking at the set classification of 4.0, once again we have a decimal, and in this case we have a decimal that terminates. And so if I have a decimal that terminates, going back to the definition that I just discussed about rational numbers are decimals that either terminate or repeat. And so we have a terminating decimal, so I can conclude that 4.0 is a rational number. So when we think about the resulting sum, the word sum implies addition. So what we're going to do is we are going to add the square root of 17 and 4.0. And if I were to rewrite these so that they are positioned above each other, above and below, 1, 2, 3, 1, 0, 5, 6, 2, 5, 6, and 4.0, we can immediately tell that these ending decimals, the 2, 3, 1, 0, 5, 6, 2, 5, 6, and I'm going to add the dots just to show that it would continue on forever, however long I wanted to write numbers, they are immediately going to drop down and be a part of the resulting sum. And so without even going any further, we can see that this is going to be a decimal. The resulting sum will be a decimal that goes on forever. It does not terminate and does not repeat. And so we can now conclude, without even finishing the addition, that we are going to have an irrational number. But just for the sake of completing it, we can see that the resulting sum of 8.1231056 and on and on and on and on forever is a decimal that neither repeats nor terminates. And so the resulting sum, so this is our answer for here. And so looking at the last question, or the next to last question about the set classification of the resulting sum, we notice that it is again a decimal that neither repeats nor terminates. And for that reason, we can conclude that we have an irrational number. And so the question is, why? Why do we have an irrational number? Well, a couple of things as far as the why is concerned. The first is we can say that the closure property, and let's write closure property applies to addition and the result will be a real number. And so that's point number one. So the closure property applies to addition and the result will be a real number. And if you look at the classifications of irrational and rational, they are not the same set classification. However, both are categorized in the set of real numbers. And so the closure property basically states that any time that you add two numbers from the same set, and in this case, the same set is the set of real numbers, will result in a number from the same set. So adding two real numbers will result in a real number. Now, the next thing is, why is it going to be irrational as opposed to rational? And the reasoning is, let's change the color, the reasoning that this occurs is that since a rational number terminates or repeats, it will assume the properties of the non-terminating, non-repeating set. And in this case, the non-terminating, non-repeating set is an irrational number. Now let's think about it. What we're actually saying with that is, if there is not a way, if I look at the example that we've worked, there is not a way to change this portion of the irrational number into a terminating or repeating decimal by adding anything below as a part of the rational number. There is not a repeating pattern or a terminating decimal that we could insert into this yellow highlight that would change the pink highlighted portion of the irrational number into something that would terminate or repeat. And so what this would result in is that those properties that I've highlighted in pink that make this number, the square root of 17, irrational, carry through to the result, making the result an irrational number. And so when you look at the explanation, your explanation is going to be that the closure property will apply to addition, and the result of two real numbers, which irrational and rational numbers are both contained within the set of real numbers, will be a real number. However, that real number will assume the properties of the irrational, non-terminating, non-repeating set.